So used as a refrigerator. So these are the equations for refrigerator. The beta is the coefficient of performance, neta is the efficiency. Now Q1 and Q2. Q1 is the heat which is rejected to the surrounding. Q2 is the heat which is absorbed from the refrigerator. Sink, which is at the refrigerator inside, is at the temperature T2, and T1 is the temperature which is of the surroundings. W is the work done by the electrical energy. Okay, and that's how the things goes here. The amount of energy absorbed from the reservoir at lower temperature is. So let us do this. So if you see the coefficient performance, okay, we have to just equate both of them. So we have, so amount of energy absorbed from the reservoir at lower temperature. So basically that's Q2. Okay, so this is Q2. It is absorbed from there at lower temperature. So therefore we have Q2 divided by the work done is equal to 1 minus neta upon neta. So therefore Q2 upon 10 joule is equal to 1 minus neta, which is 1 by 10, divided by neta, which is again 1 by 10. So this is 9 upon 10 divided by 1 upon 10. Gone. So therefore Q2 becomes 9 into 10, which is 90 joules. So therefore the answer is going to be C.